Hey guys, how's it going? Got burned up inverter here. I've owned several of these. I don't own any anymore other than to fix this one. But been getting a lot of traffic on my channel on the Centech 2000 watt inverter. I did a repair on one before. I don't know if it is this one because I did fix 3 of them. I don't know if this is the one that was in that video, but it's probably just one that I fixed. But I think something's wrong with the input side on this one, and it was the output side I fixed, I think, on all 3 of them. But anyways, we'll open it up and see what's going on. Okay, so what I found so far is this is the output board. This is what turns the high voltage DC into 120 volt AC. And there is a couple traces right here. This cracked all the way across, right there and right there. And there's a resistor leg that fastens here, it fastens over here. I'll flip it over. And you can see how how dark it is right here. The funny thing of it is, I mean, I haven't really took my voltmeter to anything, to check ohms on things, but just by looking at it, I cannot find anything that's actually burned up. There's this residue all over everything, like something blew up. I mean, unless its legs are like sticking out of the board and there's no sign of the component that blew up. But pretty much what I think I'm going to do with this is, I don't know if you guys remember, you probably go back and find it somewhere, but there was a video where I tore apart, I think it was 1,000 watt or 1,200 watt, one of these inverters, this brand, and it was just too far gone. There was too many components burned up in it for the price point of where it sat. But anyways, I saved the output board out of it, and I'd say that output board is just as capable as this one. They probably just, for a certain amount of models, just throw in the same output board. It's just limited to what the input board can produce, which is what makes the thing, be able to make what it can. There is 220, 210 amps worth of fuses blowed up. So yeah, this thing, most likely what happened here is something overheated on this board here, and the oscillator quit working. And then the oscillator quit working, then it pulled, it's going straight to ground, getting pulled straight to ground, and then this whole unit right here is just on a solid short. It's just pumping juice right into a solid short. So that's probably what popped these fuses. Now looking down in here on the transistors, for this side, nothing. I don't see anything that went nuclear. But so I'm thinking, like, what we'll do is we'll just swap out this board if we can. This board's at the garage. I'm at the house, actually, my back patio. But next time I go out there, I'll grab it. And well, it'll be instantaneous for you guys. But one of the things to consider is that since this thing blew up, 210 amps worth of fuses, even though there's a component not visually, seen to be blown up in here, maybe even it would test good, even if you went through and was testing everything on here. But once something goes through something like this, it might not work later. I mean, or it might work for a while. You fire it up and it might work for a whole day, and then next thing you know, you get the right load on there and take a crap. But we'll make an attempt at it. Alright, just doing some further diagnosing here. These FETs on this side is shorted, or at least one of them shorted. They're all parallel, so if one blows up, then they all will read shorted. And then, but the other side, basically you got 2 sides switching on and off, pulling each side to ground, which creates a sine wave. This is a modified sine wave, also mentioned, so makes a square wave. But you know, one side is shorted, one side's not. My bet is the oscillator, something happened to the oscillator, and this right here, you know, it was pulled to one side or the other, which would have been probably this side, and then it burned out this side in the process because it's not meant to be on a solid, you know, you know, switched on. You know, it's meant to be oscillating, so it can't handle that, so it burned out something. The other board that I have like this has some of these burned out, but the nice thing is that I can just pop these guys out of here, desolder them, and then replace them in the other board. So, alright, well, yeah, we'll see about once we get the other board. Alright, it's been a few days later since the last time I was looking at this. And we're in here at my little workstation. Excuse the mess. I haven't used it since last winter. But I went out and found that other circuit board. I think this was out of a 1200 or 1500 watt. And this is a 2000 watt. And the board is the same, but a little different. There's like some components on here that this one's missing, and this one has components that this one don't have. And there's some places where, like right here, there's no resistor. Right there, there's no resistor, but then you flip the board over and oh, the resistor is kludged to the other side. So, we got the output plug for the gauge, like the amperage gauge, how many watts that's, you know, is going through it. That might be off. Yeah, that might be off after we set this up because it's a different, you know, different wattage inverter. Oh, well, you know, it just plugs in. Another thing that's kind of interesting is that you have like the wires coming off this board to go to the outlets. You know, right here's one. It goes this way to go to the outlet. Where this one, in the same location, is going towards the input board. And it's all the wires are that way. It's like it's reversed. So I'm not really sure. You know, I'm probably just gonna, you know, put this one to this one, and you know, the boards are identical almost. So I don't know, maybe this was oriented in a different fashion in the other machine. I don't really know. It's very possible. But anyways, another little issue is this plug right here has 4 wires. Well, this one only had 3. But it does have the 4th pinhole right there. So I'm just going to put the 4th pin in that hole. I did flip it over to the other side, and it is connected to stuff. It's just not used on this. So another thing to note is that these resistors right here on the 2000 watt stand off, you know, so that way they can disperse heat. Or these are flush mounted. So I'd say this board here is just as capable, but maybe not for length time. You know, a great length of time is what this one was, which obviously is what killed it. This came from my uncle's semi. He uses it in his semi to run a toaster oven or a microwave. And from what I gather, I think he's even told me stories about how he ran both at the same time. And one thing about these inverters that I've discovered, I don't really use this inverter anymore. I did for a little while. But I use its cousin, which is the Tiger Claw OSP Tiger Claw pure sine wave inverter, which is 1500 watt, which is the same machine as this, except for the output board has toroids, and you know, it produces a sine wave instead of a modified sine wave. So there's more components on this board. The input board's pretty much the same, except for probably has high voltage DC of like 170, where the OSP would, you know, the sine wave one would be like 180 or something. in order to make that sine wave, the voltage, input voltage need to be higher. But yeah, I'm just gonna kludge this together. Probably use, I'm probably just gonna splice these wires in the middle and use shrink wrap on them. Solder them together and use shrink wrap, because if I don't think they'll be long enough if I try to go straight to the board and solder them in. Maybe if I desoldered it from this board and then, desoldered, I think it'd just be easier just to splice them, and I think there's plenty of room right here. There's no fans right here, so, for them to run into. But just splice it all together. These transistors were good, they tested good, but I did cut the legs on one to test it because it was showing up shorted because the one beside it was. These are all good, and the same way with this board, one side's all good. So I'm going to desolder those, and I'll just put all the good ones from this one into that one, and then hook all the wires up. So once again, I just closed out the take, and I realized that I started talking about something, then went off topic, and didn't get back to it. One of the things about these inverters and the OSP Tiger Claw, and there's also another one out, it's called Ramsound or Ramsund. They have an inverter that's made by the same third party, whoever it is. It's a 1500 watt pure sine wave. But one of the things that is bad about them is they don't have very good low voltage shutdown. Like, they'll go clear down to like 9.5 volts. Like, you already just destroyed your battery before they shut off. Plus, you can put whatever amount of load on this thing, and it'll just continue to try to do it no matter if it can't do it or not. It'll just try and try and try until something like this happens. The components got overheated, the whole board's got overheated, and finally it just failed. Another thing about them is, which makes them good in a way, is the fact that they don't shut down, but it's bad for the machine. The machine will fail. But like, you can put like stacks of inductive loads on these, either machine, the sine wave or this one, and they won't shut off. And like where the other inverters is better, like say you're running a computer and you go over and turn on a drill press, it'll momentarily shut down enough to shut your computer off, and it's annoying as can be. But the inverter is just trying to protect itself, where this thing here won't do that. They'll just run until they blow. So it's good and bad, and it just depends on what your perspective is with it. But I particularly rather have this thing just do the job in the garage, because I did have one of them ones that was fidgety like that, or several of them that was fidgety, and I ended up unbolting them and looking for something else, and I came across these. They wasn't fidgety, but after getting to know the machine and knowing what's going on, it's all of a sudden I could end up with like this. Something's going to go up in smoke. Alright, so this is the new board, and I got the transistors changed out, and it was a heck of a thing to change those. They had blobs of solder. You see how much solder was in there? That's all the solder that was pulled up. I actually used the big dog stuff to put it back in, because some of the pads got ripped off, and it was a mess. And then that 3-prong plug, I actually just desoldered it and put the 4-pin in its place, so it'll plug right in. But all we gotta do now is hook the wires up. Alright, got all the wires attached. You solder them all together, use heat shrink, except for one. This one right here is soldered but electrical taped, because I did the classic, solder together, and then, oh, I forgot to put my heat shrink on there. But, oh well. We're not going to be able to do, I might be able to hook this up and do a partial startup, like a light load. I don't have all the fuses. I forgot when I went out and got the circuit board, I forgot to get 8 30-amp fuses. So I only got 2, one on each side, so it should be able to do, it should start up with that and do a light load. It may or may not, but I think it will. Alright, we'll see if I can find some kind of 12-volt power supply and See if this thing will do anything. Alright, we got a test rig hooked up, and it took all kinds of stuff to get this to go. Started off trying to use a 12 volt power supply, 1.2 amps, and that wouldn't fire it up, so I took two of them paralleled. That still wouldn't do it. And then I put a battery charger on it, which is reading 3 amps. Battery charger will not do it all on its own because it's has to have some kind of voltage already on the source or what you're sticking it on in order for it to even turn on. But anyway, it is powering up this leg lamp from Christmas Story. That's like one of those 40 watt equivalent CFL bulbs that's in there. That's probably all I could run on this at this point with, you know, there's only 2 fuses in there out of the 8 that needs to be in it. So right now I probably have, you know, you couldn't do much with it, but it is passing a light load test. I'll take it out to the garage and do a heavier load. But there's no point in putting any screws in this or doing anything else until I can get some more fuses in there. But until then, I'll see you guys out there. Alright, got the inverter all back together again, and I'm going to test it out, but we're not going to be able to run it up to its full potential just because I don't want to go through all the bother of disconnecting that inverter. It's bolted to the wall. There's buses, 2 buses bolted to the power inputs. In order to take that out, I have to disconnect the solar panels from the charge controllers, disconnect all these batteries from each other. And I'm not going to do all that just to test this thing, and you know, I wouldn't want to use it on a daily basis anyway because it's modified sine wave. So you know, I'm about running up to like 800 watts for a little bit, you know, running off of one set of those cables. But if it can do that, it'd probably be able to do what it's supposed to do. Alright, got it all hooked up, and it's pitch dark in here. Moment of truth, see what it does. There it is. Alright, go around the garage and see what we can do with it. Alright, got all the lights and stuff on here. Stereo. No, we got 1 bar on there on that load meter. I thought about sticking my coffee in the microwave just to see what it'd do. I figure if it doesn't have enough input, it'll shut off due to low, you know, like if I get too much voltage drop. But I'm afraid I'll overheat the wires. I did double it up. Like I got, you know, the jumpers plus I ran a couple extra leads down to it from another battery. Yeah, I really wish I had it on there, but it's just too much work to get it to go on over there for a test. But I'll go in and see. We'll see about the microwave. Alright, we'll set this for 1 minute. I shut off other components, the lights and the stereo. Generally, I would leave those running, even with the 1500 watt OSP tiger coil. But given the cabling we got, I just turn on enough lights to be able to go, you know, see to be able to get to the other room. But I'll set this for 1 minute, and hopefully nothing bad happens to where like I'm burning up stuff. But here goes. Okay, there's the load meter. I see, I think 5 bars. See what this cabling's doing. I would say that yes, it would overheat, but for 1 minute it could probably do it. Alright, ran for a minute. That microwave's noisy with that inverter. Modify sine wave. Alright, looks like the inverter passed the test. It ran 1100 watts because that's what this microwave uses running despite what it says right here. It's just what, 700 watts cooking power. So a 2000 watt running 1100 watts is totally acceptable, because pretty much when you buy something like that, you should be buying twice what you're probably going to use. You know what I mean? It's 50% capacity is probably the ideal. When you buy a inverter like that, you want to look at, you don't want to be going much over 50% capacity for long periods of time. But anyway, I'm going to enjoy my coffee. Thanks for joining me on this video if you watched it all the way through. See you guys next time.